Today we study the Calculus 1. The topic is Implicit Differentiation. So now look at, from the definition, capital F x y equals 0 is a function. The corresponding function y equals yx satisfying capital F x yx always equals 0. Corresponding y is called the implicit function. Why? What is our implicit function? So now I will give you an example. Let sin y plus x e y power equals 0. From the equation, we cannot solve for y in terms of x. But in theory, y equals yx always satisfies sin yx plus x e yx power always equals 0. This means x is given in theory, y will be fixed. X is equal some number. We can get some special number of y. So in theory, y equals yx, always satisfying this expression. At this time, we cannot solve for y in terms of x. But in theory, there are some function relationship between x and y. So y is called the implicit function. Of course, you ask yourself the question, how to find the derivative of y? How to find it? So now look at the derivation rule of the implicit function. The method derivation about x on both sides of the given equation means the equation is given. Do the same computation on both sides. What computation? Derivation about x on both sides. How to do? Pay attention to the variable y is a function of x. So, the function of y in theory is a composite function of x. Try to use the composite change rule, means the change rule for y. Y is a function of x, so the function of y is a composite function of x. According to the method, do the derivation about x on both sides, and the function of y is regarded as the composite function of x. So now look at example 1. Try to find dy over dx means y derivative for x. If given x squared plus y 5y cubed equals x plus 9, how to do? Yes, do you remember the method? Do the derivation on the two sides, and then the function of y is a composite function of x. So now do the same computation. Derivative from the left side and do the right side. Differentiable for x, differentiable for x. Together we can get, in your mind, y equals yx. This means the function of y is a composite function of x. For example, this term, 5y cubed. So we can get x squared equals double x. 5y cubed equals 5 times 3 equals together 15 y squared times y prime, y prime, because y equals yx. This means y is not a constant, y is a function of x. Pay attention to this term, equals 1 plus 0. From this, we can get dy over dx equals the expression. This means in the implicit function, y prime is an expression of x and y. It is our final result. So now look at example 2. Sin y plus x e y equals 0. Try to find f prime x. How to get it? Yes, do the derivation on the both sides. So we can get Sine y equals cosine y. The function of y is a composite function of x. So time y prime. This means sine u prime means cosine u time u prime plus u time v. X prime equals 1. Copy another expression ey plus x doesn't change plus eu time u prime equals 0. So in your mind, you have this kind of idea, y is a function of x. And then we can get y prime means f prime equals the expression. The expression is a function of x and y. It's the final result. So now look at example 3. Try to find the equation of the tangent line to the given curve x cubed plus y cubed equals 3xy at the given point 3/2 and 3/2. What is our question? Try to find the tangent line. How to get it? There are two conditions. The first, passing some given point. The condition is given. Another condition, try to get the tangent line slope. How to get the slope? The slope means the almost meaning of derivatives. So the first, we can do the derivative for y. Do the same computation on both sides. X cubed equals 3x squared plus y cubed. Remember, the function of y is a composite function of x. So equals 3y squared times y prime. Keep in mind, okay, y prime equals 3 times y plus 3x times y prime. We try to find y prime. So y prime equals the expression. In order to get the tangent slope at the given point, taking the given point equals minus 1. Minus 1 is our tangent slope. The point is given. We have getted the tangent slope. So we can get the tangent line equals y minus y0 equals k times bracket x minus x0. Taking in the given point, taking in corresponding the tangent slope, together we can get the formula x plus y minus 3 equals 0. It's our tangent line equation. Keep the mind in your mind, okay? The idea means try to find the tangent line to condition the given point, the tangent slope according to the first derivative. So now we can get the corresponding summary. Derivation rule of the implicit function. How to get it? Yes, the method do the derivation about x on the two sets of the given equation. How to do? The function of y is a composite function of x. Try to use the change rule for y. We can get the corresponding the implicit differentiation. So now look at the questions. Question 1. Try to find the equation of the tangent line to the given curve. This expression y cubed minus xy squared plus cosine xy equals 2 at the given point 0, 1. It is similar to the example 3. How to get it? Two conditions. Condition 1, the given point. Do you remember condition 2? Yes, condition 2, try to get the tangent slope. So, using the implicit derivative, we differentiate both sets. So we can get corresponding y cubed equals 3y squared times y prime. Y. The function of y is a composite function of x minus x doesn't change, y squared equals double y times y prime minus x prime times y squared plus cosine u equals minus sine u. So minus sine u and times u prime. It is the change rule. U prime means x prime 1 times y plus x times y prime equals 2 prime. 2 is a constant, so 2 prime equals 0. From the equation, we can get y prime. It is the y prime at any given point. The given condition means at the point x equals 0, y equals 1. So, taking the given numbers, 0, 1, x equals 0, y equals 1. X equals 0, this term equals 0. X equals 0, x equals 0. Together 0. Y equals 1. Together equals 1 over 3. It's our tangent slope. Pay attention to 0, 1, the given point. Tangent slope 1 over 3. Together we can get the corresponding tangent line. Y equals kx plus b. B is our special number 1. So it's the tangent line. Now look at question 2. The given equation x full power minus xy plus y full power equals 1. It's a given equation. In this equation, y is a function of x, but we cannot find the function y in terms of x. So try to find it. Try to find the value of y double prime at the given point 0, 1. How to get it? We only y first prime. How to get y double prime? Do you remember the high order derivative step by step? The first step we can get the first derivative of y. So we can do this. Do the same computation, derivation on both sides about variable x. So the first term, x full power equals 4x cubed minus 1 times y minus x times y prime plus. This means u full power equals 4y cubed times y prime equals 1. 1 prime equals 0. Together we can get y prime equals y prime. At a given point 0, 1, it is a constant y. Any derivative means some limit. If the limit exists, means some real number. So y prime at the given point equals 1 by 4. And then we can get, again, derivation about x. The first time, again, we can get double prime. So we can get the following, the first term. Do the same computation, derivation every term. The first equals 12x squared minus y prime minus y prime doesn't change time x and time 1 minus x doesn't change y prime 1 time prime means y double prime means the second derivative plus 12y squared times y prime times y prime 4y cubed times 1 prime itself again means second prime means second derivative equals 0 prime 1 time. 0 is any constant, so prime equals 0. So equals 0. We can get y second derivative means the double primes y prime equals at a given point. Anyway, it's the equation for any points x and y. So now, taking the special values of x and y, x in this expression, x equals 0, y equals 1. How about 1 prime? Yes, the first derivative equals 1/4. So we can get the final result y double prime equals -1/16. Anyway, y, the second derivative, is a real number. It's some special limit equals this number. This is our method 1. Do you have another idea about the question? Yes, I have. The method 2, how to do. It is our given equation. How to get? Directly, we can get y prime. Y prime is a function about this. Y prime is changeable. We can get y prime equals this expression. Of course, we can get y prime value at a given point. Y prime at a given point 0 and 1 means x equals 0, y equals 1. At this time, y prime equals 1/4. How to get 1 double prime? This is our y prime expression. How to get it? Yes, 1 time. We will do the same computation about this expression. So y prime 1 time become 1 double prime, means the second derivative. This expression, we can look at f/g. Do you remember the derivative for f/g? Yes, f prime g minus fg prime over g square. Yes, similar meaning. We can get this. Maybe the idea is very easy. So we can get corresponding this expression. This expression x equals 0, y equals 1. How about y prime? Yes, this number. X equals 0, y equals 1. At this time, y prime corresponding to constant equals 1/4. Together, we can get the constant y double prime equals -1/16. Compare the two values of method 1 and method 2. They are the same. So now look at question 3. Try to find the implicit equation of xy minus ex power plus ey power equals 0. And find y prime and y prime at a given point value. Let y equals yx. Replace y in the following equation. This means, in theory, the function y of x always satisfying this expression, so we can get this expression. We can do the same computation, means derivation about x under two sets. So we can get the first xy prime for x, ex prime for x, ey prime for x, 0 prime for x. Do the same computation, means derivation about x, and then we can get the first 1 times y plus x times y prime minus ex prime equals itself. How about ey? Yes, the function of y is a composite function of x, so equals ey times y prime. Remember this term. You cannot omit this term, otherwise you are wrong. From this expression, we can get y prime. So y prime, we have found it. How to get this number? X equals 0, so we can write it. X equals 0. In this expression, x is given. How about y? Yes, from this. Then in this given equation, if x equals 0, taking in x equals 0, x equals 0, there is one and only one solution for y. Y equals 0. So in this expression, x equals 0. How about y? You can compute by yourself from the original equation. Y equals 0. So x equals 0, y equals 0. Together, 1 minus 0 over 1 plus 0. So equals 1. It is our final value. Final value about y prime and y prime about x0. To this question, remember in this expression how to take the values of y, how to get the value of y from the given equation. So now class is over. See you next time.